Thank you for coming to my presentation. Now let's get started. So why are we here? Is it our shared enthusiasm for the captivating world of hazardous waste? Well, yes, obviously, for me at least, but also because the Resource Conservation and Recovery Act, or RCRA for short, can be complicated and convoluted. Trust me, I know. As a hazardous waste inspector of 6 years, where interpreting, teaching, and enforcing these regulations is the main focus of my everyday job, I still, even as recently as last week, find myself flipping through the pages of 40 CFR 260 through 273, searching for answers to questions that have stumped me. So sometimes all of us need a little help understanding RCRA. I have no doubt that many of you here today are familiar to some degree with RCRA, or the term cradle to grave, where you're required to manage your waste from the point of generation, the birth, or the start of the waste journey through its transportation until it reaches its final destination, when it is treated, disposed, or completely recycled. In this presentation, I will go over one of the most important key steps in the cradle to grave process, making an accurate waste determination. When are you required to make a waste determination? At the point of generation, before any dilution, mixing, or alteration of the waste, before treating or changing the waste properties. Now, I know that some of you are already jumping ahead and wanting to ask, what if I don't know if it is hazardous at the point of generation? What if I have to take a sample and send it to the lab? We will get to that later in this presentation. First, we need to cover the basics. To help make an accurate determination, you will always need to answer the following questions. Whether subconsciously, out loud, or documented, eventually you'll have to document. Is the waste a solid waste? Is the waste excluded in any way? Is the waste a listed waste? And finally, does the waste have any hazardous waste characteristics? The RCRA definition of solid waste is any waste that is solid, semi-solid, or liquid and is being discarded, which means it would be at the full end of its life cycle or spent and ready to be transported to the proper disposal facility. These pictures look like waste, sure, but they might be excluded from the definition though. Okay, is the waste excluded? Once you've determined that you have a solid waste, then you'll want to find out if it falls under any exclusions. There are many exclusions, but it can be easier to keep in mind that there are four main overarching categories. Materials which are not solid waste, solid waste that are not hazardous waste, hazardous waste that are excluded, or laboratory samples. To give some more specific examples of excluded waste, there's domestic sewage, agricultural waste, legitimately recycled, reused, or reclaimed waste, which, by the way, are now considered hazardous secondary materials, or HSM, if you're claiming this exclusion. Then there's universal waste, used oil, and special wastes, including mining and mineral processing waste under the Bevel exemption. The next step is to determine if the waste is a listed hazardous waste. There are four specific categories of listed waste that can be split into two broader categories. The two categories include listed wastes that are generated from common manufacturing and industrial processes. Those are the F and K listed wastes. And then there are wastes that are generated from pure and commercial grade products that are unused. For example, a chemical product that needs to be discarded due to expiration or surplus. These are the P and U listed wastes. Let's start with F listed wastes. These wastes are from common manufacturing processes, but they are from non-specific sources. So they can occur in various industries rather than a limited or specific set of industries. They are split into 7 broad groups depending on the type of manufacturing or operation. 3 of these 4 groups include spent solvents, electroplating and other metal finishing wastes, and multi-source leachate. K-listed wastes. In Arizona, we don't see these as often as F-listed waste because the specific industries aren't very prevalent in the state. K-listed wastes are generated in specific sectors of specific industries and manufacturing processes. Hence, the K-listed wastes are known as source-specific wastes. These source-specific listed wastes are found in 13 industry groups. Some of these include pesticide manufacturing, which can be seen in the photo to the right of the screen, petroleum refining, veterinary pharmaceutical manufacturing, explosive manufacturing, and iron and steel production, to name a few. U-listed wastes. U-listed wastes are toxic wastes and come from virgin materials that are being discarded due to expiration or have become off-spec somehow. I like to think of the U in U-listed as unused. U for unused. These listed chemicals wouldn't be mixed or used with anything else. A very important part for determining if your waste is U-listed is that the listed chemical must be the sole active ingredient used for the product's intended purpose. U-listed wastes are chemicals that are toxic to the community and environment due to the potential to migrate and persist through the environment if released. That's why even their container and spill residues would count towards your total quantity or weight of hazardous waste generated. But they are not as acutely toxic as our next listed waste. P-listed chemicals are acutely toxic, and like U-listed waste, come from virgin materials that are being discarded due to expiration or unneeded or off-spec. The example that can be seen in the right-hand corner is aluminum phosphide, which is used for fumigation, a poison. That's what I like to think the P stands for, poison. Believe it or not, but nicotine, what's in your cigarettes, is considered an acutely toxic P-listed hazardous waste. The nicotine gum and lozenges pictured on the left are exempt, however, and so are nicotine patches. This exemption was made by the EPA to help healthcare facilities and pharmacies avoid being quickly bumped into large quantity generator category. The center image is an e-cigarette or vape pen. These are not exempt. The nicotine liquid inside these vapes are considered acutely toxic, and when deemed waste, they become a P-listed hazardous waste. On another note, because P-listed hazardous waste is acutely toxic, It is the only hazardous waste containers that must be triple rinsed in order to be considered RCRA empty. Once you've accurately determined if the waste is a solid waste, if it has an exclusion, or if it's listed, you'll turn to checking for any hazardous waste characteristics. Those are ignitability, corrosivity, toxicity, and reactivity. Ignitability is when a fire can occur under certain conditions, spontaneously combust, or have a flash point less than 140 degrees Fahrenheit. Examples include some solvents, alcohol, and acetone. This video shows that ignitability is of not the liquid acetone itself, but the vapor that comes off of it, aka the flash point. You can see that the acetone has a lower flash point than the mineral spirits. Corrosivity is when the waste is an acid with a pH equal to or less than 2, or a base with a pH higher than or equal to 12.5, and is capable of corroding metal containers. Some examples of corrosive waste include sodium hydroxide, nitric acid, and sulfuric acid. Notice the nice looking containers on the right are plastic versus the corroded metal containers on the left. Please ensure you're using a compatible container for the storage of your hazardous waste. Reactivity. That's just explosives, right? Well, there is a bit more to the definition. When it comes to reactivity, there are 4 main properties that define the characteristic. A waste is hazardous for reactivity if it is normally unstable and readily changes violently without detonating, or if the waste is capable of detonation or explosive reaction when subjected to a strong initiating source or heated under confinement or at regular temperature and pressure. A waste is also considered hazardous for reactivity if it reacts violently with water in any way or form. Or a waste can be characteristic for reactivity if it causes a reaction that generates toxic gases, vapors, or fumes. Some examples include dry picric acid, ethylene oxide, and of course, explosives. Toxicity. Toxic wastes are harmful when ingested or absorbed through skin, eyes, membranes, etc., and can contaminate the local environment, including groundwater. There are also 39 specific waste codes for things such as heavy metals, pesticides, or other organic chemicals that have a threshold that, when reached, are extremely hazardous to handlers and the community. That would be T-CLIP. So far, we've covered the basics for making an accurate hazardous waste determination. There were or are 6 questions you would be asking yourself. Have I identified all of my waste streams? Are these byproducts or unneeded products or spent materials considered a solid waste by definition? Can this solid waste be recycled or excluded from the regulation? Is this waste stream considered to be listed? Does the waste have any hazardous waste characteristics? And finally, a very important final step. Have you documented your waste determination? That leads us to the next topic: how to document your waste determination. Generator knowledge is a way of making a waste determination. However, it still needs to be documented somehow. There are a few ways that you can document your knowledge that a waste is hazardous or not. For example, you may use a detailed facility-specific process flow diagram or a narrative description of the process that generates the waste. You can also document the chemical makeup of all ingredients or materials used in the process that generate the waste, such as safety data sheets, product labels, or substances used in the process that generates the waste. And finally, you may use a lab analysis of the waste to make and document your waste determination. With the data that you've obtained through approved sampling methods and laboratory analysis of a waste stream, you may use that documentation for any waste generated from that same process, as long as it is using the same ingredients or materials too. On this slide, you can see 3 examples of generator knowledge documentation used to make a waste determination. A materials product label, or SDS, on the right and left can be used if you know that no other materials were added to the waste stream. A process flow diagram shown in the middle can show what inputs and outputs are in the process that generates the waste. Using a flow diagram, you can identify which outputs are waste. Say you've discovered an output or a new waste stream, but you don't know through generator knowledge if it is a hazardous waste or not. When do you label your waste? If you are waiting for a lab analysis to come back to make your determination? Well, at the point of generation, when the waste is containerized, I recommend that you label it hazardous waste, but also pending analysis. That way, you are covered if it does come back to be a hazardous waste, but you are also documenting by writing pending analysis that you are still waiting for your lab analysis to come back to make a final accurate waste determination. So let's talk lab analysis. This can be a whole foreign world if you haven't been exposed to it yet. So this slide is here more for you to use as a reference or to go back to when you are trying to fill out a chain of custody for a sample of waste that you're sending to an environmental lab. The test methods for evaluating solid waste are known as SW846, or the Compendium, EPA's official collection of methods to comply with RCRA. There are many different test methods under SW846 that must be used for testing different analytes or the characteristics of your waste. For toxicity, there is really only one method, and that is the toxicity characteristic leaching procedure, or TCLIP for short. For ignitability, there are a few more options, but your best bet is to use the SW846 test method 1030 for solids and 1020B for liquids. For corrosivity, you can use the litmus paper to test for pH, or you may send a sample to be analyzed at a lab using test method 1110A. Lastly, there is reactivity. There are no analytical test methods for reactivity. The best way to determine if your waste is reactive is to go back to the definition of reactivity and determine if the waste fits under the definition. I believe we will provide you all with a copy of this PowerPoint presentation so you can reference this slide later. If a visual guide is more your thing, here is a flow diagram or depiction of hazardous waste determination process that we just went through. So why does this all matter? Sometimes I run into individuals that might find the whole waste determination process and the documentation of it to be quite cumbersome and extensive. And well, sometimes it can be. But I like to remind those people of the intention of these regulations and the reason why we are required to do this. It's because sometimes there can be many processes or different waste streams at your facility, and we may assume a waste stream is not hazardous that might actually be harmful to the environment or human health in some way we didn't consider. It helps us to take a hard look at our processes in a systematic way and see where our waste is coming from. It keeps us accountable of what we generate, and it helps ensure that nothing hazardous ends up in our landfills. We all want accurate waste determinations because it affects our families, pets, and the spaces we inhabit. To ensure that the bad stuff is accounted for and disposed of correctly, so that we can all go home safe at the end of the day and have the opportunity to live a healthy, clean life at home. We have some additional resources for you all to look up later on your own accord. This helpful link will take you to EPA's convenient and user-friendly table of solid wastes that are not hazardous waste, the exclusions. This link will take you to EPA's page summarizing what are listed and characteristic hazardous wastes. It also includes many more links to more guidance sheets and resources. Very helpful. And that's the end of my presentation, but not the end of the session quite yet. Time for questions. And I know you've got them. Please write in your questions here or raise your hand if you would like to voice your question. I am here and ready to take them. But if you'd rather email your questions, here is a designated team email, great for emailing any hazardous waste questions you may have. Thank you.